Okay, hi everyone. This is part 2 of your last lesson, which is 4.6. So 4.6 talked about non-linear regression. Our previous lesson talked about linear regression. So I'm going to do a similar video to show you how to fit data into non-linear regression patterns or trend lines. We talked about that at the end of the last Excel video. But this time I'm going to look at our first example, which is the same data that comes from part 1. Okay, so our example there. And example 2 will be a different set of data that we're going to fit in a similar fashion. So for nonlinear regression, it's the same method as linear regression in that we're going to highlight all of our cells that have data and go to insert, and remember we're going to click on scatter plot. Okay, and we want just a plain scatter plot showing data. All right, so we're going to click that. I'm going to just click and hold and reposition it to be closer to the data. And here I can click and delete the chart title since we're just looking at the data. So you can see it's following kind of an upward exponential trend, right? And if you remember, when we actually graphed it, I told you that the function f at x was v cubed, right? It was velocity cubed. Now what you're going to see is using Excel, we're going to get something very close to it. We're not going to quite get that table. So I gave you v cubed, if you remember from our lesson, mostly because that was an even number. You'll see that it'll be a little bit different when we do the trend line. So to add the trend line, when you're clicked on the chart, remember you go to the Design tab here at the top. And on the left, there's Add Chart Elements. So we can select that, go down to Trend Lines, and it gives you a few options, but it's not all of the options. So for our case here, you can see exponential looks relatively close, but previewing it, it's not going to be as exact as we'd like it to be. So I'm going to click More Trend Line Options here. And when I do that, you'll see that all of the options come up here. So linear isn't a good fit for this data, right? As you can see, this data is kind of curving upward. Logarithmic as well. Okay, logarithmic is not a good indication. Exponential, which we just saw, is pretty close. Okay, but remember, it's true exponential growth. So if I go down here and I click Display Equation, it's a function of e. Okay, and e is an exponential function. So it's going to grow at a faster rate than if we did different types of trend lines. So I'm going to click back to this trend line, go over here and make sure I'm clicked on trend line options. And the one that I want to use is called power. Okay. The reason for that is if I select polynomial, it wants to do it as whatever order I select. This is order 2, meaning our highest order power is x squared. But it has an x squared term, an x term, and the constant, which is different than how we saw in lesson 4. In part 1. I can go to order 3 and get the cubic term, but still I have the squared term, the x term, and the constant. So it's always looking for a polynomial made up similar to when we talked about quadratic equations. Okay, so you can select your order, and you can see it does fit very well, right? So this would be a good option, but it's a far more intense equation. If I select power, all right, you can see here that the power equation is very similar to what we had in ours. It does not have a y-intercept by default in here. But if you remember, our equation was 0.075, and then it was v cubed. Okay, so I'll add the cubed in a second, plus 13.3. Okay, so to add the cubed, I'm going to highlight this and go to Format Cells and select Superscript, making sure I highlighted only the text that I wanted to cube. Okay, so that's just one way you can add it. You can also insert equations in Excel. So you can see that this equation here has 0.0718, close to what we had, but the x to the exponent is a little different. It's 3.0169, so it's not quite cubed, right? And that's because Excel is going to try to fit this curve almost exactly. Where when we selected v cubed, we were using that as our best estimate and a value that's easier to calculate by hand. So what you're kind of seeing here is, when you're fitting this, it's going to look different and slightly different in Excel, but our methods were similar, okay? So I selected power. You can see it fits quite well. And actually, if I click here, the exponential, or sorry, not exponential, the polynomial actually fits slightly better, okay? So it's totally up to you on which one you choose to pick. I usually like to use exponential, linear, and logarithmic more than I use the rest of them. For the power, if it fits certain sets of data, like this one fit it really nicely, almost x cubed, it is a nice option. Okay. So our second set of data, we have x from 1 all the way to 16 with some gaps in the middle. And the y variable is actually decreasing. So it's going to make a different type of exponential graph. So I'm going to just delete this equation from our previous example. Highlight all this data once again. Go to Insert. Click on the scatter button and make sure it's just a scatter plot. So you can see the difference. I'm going to just move this so it sits in a better location. That as opposed to trending upward, it's trending downward. So as the x value increased, okay, the y value decreased. Oh, I deleted the chart by accident. I meant to delete the chart title. Okay. So if I want to fit this to a graph, it's going to look a little bit different. So I'm going to click on my chart, click on the Design tab at the top here, go back to Add Chart Element on the left, go to Trend Line, and again, I'm going to pick More Trend Line Options. Now, if it doesn't come up to show the options here, they're actually under this button here that says Trendline Options. The other options are just changing the fill color. So in this instance, if I want to change it to be orange, like in the last video, and maybe I don't want it to be dashed, I want it to be whole, I can do that. So if I click this Trendline Options button, once again, I'm going to try and select the power option. And you can see it fits it nearly perfectly. And actually, it does fit it perfectly. Okay, so I set this up so I can show you an actual example. So if I click Display Equation, it's displaying in an odd spot, but again, we can click and hold and move it. It's y equals x to the negative 1, which if you remember, x to the negative 1 means that you can change that exponent to positive if you move it from the numerator where it is right now to the denominator. So this equation can be written as y equals 1 divided by x. Okay? Or if you want to see it written using the same kind of way I've done it in the past, y equals 1 over x. Okay? That's a terrible 1 over x. I'm going to try and draw it a little bit better. Okay? So you can write it like that. So that would be an example where f at x here is 1 over x in your problem. And it gives you a graph that looks something like this. Okay, so downward trending. In other words, as x increases, y decreases. Okay, remember back to our first unit, the difference is, for the second example, y is inversely proportional to x. And in the first example, y is directly proportional to x. In this case, x cubed almost. All right, just to bring it back to our first unit. So that is simply how to do a non-linear regression. Okay, it's the same methods. It's just you can see that you're fitting it to different types of data. So for linear regression, if it doesn't follow a straight line, it doesn't work. But for non-linear, you can fit a lot of different types of data using different curves. All right. So if you have questions on using this, especially in Excel, send me a message or on Teams or send me an email. If you want to get together, I can actually share a screen with you and we can go over a few more examples. You just let me know. This piece is where you'll actually see this type of statistics being used. You might use it in your job to actually correlate data. Okay, so that's it. This is the last piece of our last lesson for this course. Thanks for watching all of my videos, and good luck on your test.